Hello everybody, Cam Sweet here from the Garage Connection, coming to you today with a video about the hydraulic control valves on your mini excavator. So what we're going to do, we're going to talk about how they're kind of set up, how they work, how the fluid goes through them, and then most importantly, we're going to start to work on a way to make the joysticks a little less jerky. That seems to be a common problem across the whole fleet, if you will. Everybody seems to say, hey, this thing has a hair trigger and it's jumpy, it's tearing up my yard, whatever it may be. So we're going to talk about possibly some things we can do to make that go away. So stay tuned for more. As we can see, we got both of these machines pretty well torn apart. But what I wanted to do is I wanted to take a look at the actual control valves on these excavators, figure out how they work, how the fluid goes through them, and what we can do to maybe slow down the jerkiness, like I said. So we're pretty invested in these things right now. What we have here, this is the control valve block for the front accessory, the aux drive, okay? It's a cast unit. It's got a symbol on it that says Y2, which apparently means absolutely nothing if you were interested in trying to find out what Y2 means. And what we have here is we have what's called the A port and the B port, okay? So this is obviously to one end of your hydraulic accessory, and this would be to the other supply, return supply, whatever you want to call it. Then we got some ports along the inside of it here. Now this one in the center, this is going to be where the fluid comes from. And this port, when all those plates kind of stack on from one end to the next, the fluid sort of winds its way between all these middle ports. We got this round hole that's going to have a check valve in it. We have this, I guess you could call it like a quarter of a circle hole. This is also going to be for pressure, but it's going to be for a different reason that I'm going to explain later. And then lastly, we have this half moon back here. That's going to be the return side. This is going to go directly back to your hydraulic tank or to your cooler and filter kit because you we're smart enough to grab one and put it on your machine. So at the very end of the valve block here, we've got the supply hose coming in, and then this would be where the return line is. Scratched on, we got the return line right here. And what happens essentially is the fluid enters this supply line, it travels down at a 45-degree angle, and it comes out of this little hole and this larger rectangular hole. Now, if we come around to the front of this valve body, you can see all the way through. Let me get that in focus here. We can see all the way through on this one, but we cannot see through on the center. I'm going to explain why all this is important and why this little check ball right here, this little check valve is important. To truly understand what's going on here, you got to understand how a DCV works, or a directional control valve. So I drew one out right here that is roughly what we have. It's a little bit difficult to add three-dimensional features to a two-dimensional drawing here, but essentially we have the valve body, okay? And then this red part inside represents the spool. Now the spool is what's in the center of the valve, and it controls the movement of the fluid. What the spool actually looks like is this right here, okay? This is inside of your DCV. Now on this end, there's a spring, just like this, and that's what's going to return the valve to center if you release the handles. Obviously over here we have a connection for our handles. This configuration is extremely popular in the hydraulics world. So essentially, you have a pressurized fluid source in these valves that exist in the center. Pressurized, okay? Then we have the connection to the A and B port up here. Now, if this was going to a ram, you'd have one end go into the cap, the other end go into the rod end of the ram. But because this is the auxiliary hydraulic circuit, it could be into your auger drive and back out the auger drive. It could be whatever, a million different things that they come up with, all right? And the DCV is what's going to control the flow of the fluid, all right? So what happens is if I want to make a movement of the DCV using the handle and change the state of this. Now, if this DCV, let's say we're going to push, right? We're going to push on the handle, and that in turn is going to push the DCV down. These little cutouts, let me ditch this thing here. These little cutouts in the DCV are what's going to allow the fluid to flow around the little breaks in the valve body, okay? Because the fluid that's trapped in here in the A side, it cannot jump over to the low pressure side and go back to the tank. It can't do it because it's trapped by the metal surrounding the spool, okay? So I make a movement. Instead of this little dished cutout only existing inside of where the fluid is trapped, it moves over. It allows the fluid that's trapped inside the B side to go around the corner and vent back to the tank. At the same time, the fluid that's in the A side, when this valve slides over, it exposes it to the high pressure area, and that fluid is allowed to go around the DCV and out the A port and go to work for us, okay? The center part of it is what's controlling the direction that the fluid goes. Right now, because the cutouts are kind of in the middle and they're also trapped by the walls, the fluid can't go anywhere, okay? So it just simply winds its way through all the stacked up DCVs. It gets to the end, loops around, goes back to the tank. But when that movement is made, this center piece blocks off the fluid flow going to our, in this case would be our return or our low pressure side, and it forces all that fluid to go around into the high pressure side, jump through this cutout and out of the A port and go to work for us, right? That's how these DCVs work. Now, in a previous video, I had mentioned that they are what's called open versus closed center. I said that they were closed center, and it's right for a different type of DCV. But in this case, with these specific control levers, these are considered, they're open center, but it's not really an open center, it's more like a tandem center, all right? Because the fluid that comes out of the pump, if no valves are being actuated, it returns to the tank, basically pressureless, they call it. It's not riding the relief valve. But the minute you make a movement, that flow path is blocked and then it can't go anywhere. The next part we're going to talk about is what's called the load check. So what I did, I put the DCV back inside the valve here, or the spool rather. Okay, so as I said before, this center part right here, all the fluid is winding its way just kind of around the corners and daisy chaining through all the valves. But if we make a movement, and in this case, we're going to make a movement down with the DCV. Okay, so as you can see, that blocked off the port. This little raised edge right here goes into that, and now the fluid is trapped. And along the other side here, it's also trapped by the wall on this end. So this fluid now has no path to go, all right? But as I said before, this is also a pressure source up here. These two are connected internally at the entrance to the valve body. So what happens here, and it's tough to see, but way in the back there, let me try to, try to get something better. Way in the back here, there's a cutout. And that cutout goes down, and this is where our load check would be right here. So what's going to happen is that the fluid is going to lift the load check off its seat, and it's going to allow the pressurized fluid to flow inside of the body of this DCV and go ahead and jump over to the pressurized ports and go to work for us. If we took this out and we looked at the same thing, again, the movement that I just made, when I move this down like that, okay, down inside the body, the path is blocked off. The fluid pressure instead will go through these quarter round cutouts, lift the spring check off of its seat, and it will allow the fluid to flow inside of the valve body. That fluid will jump around this cutout and go out our port and go to work for us. At the same time, the fluid that's in here will go around through this cutout area here, this little notched area,
it will flow under no pressure into the return side and go back to the hydraulic tank.
Now, this load check feature is extremely important because it ensures that if one hydraulic accessory is stealing all of the pressure and you make a movement on another one, so let's say, for example, you have a boom in the air and you've got a rock inside of a grapple, okay? And you just want to move the excavator. If you're trying to lift the rock grapple at the same time as move the excavator, if you didn't have load check, the force of the weight on the rock grapple and on the boom, the fluid would, instead of coming from the pump, it would fly out of the pistons and go to move the excavator, and your load would drop. So the reason they put those load check valves there is to make sure that that doesn't happen. So if you actuate a valve, unless the fluid is able to overcome the pressure that's already inside the DCV, it will not move, it won't drop the load for you. Extremely important to make sure that this feature is present on your machines. It should be, but just keep an eye on it. The next thing we're going to talk about is some improvements that we can make to these valves, potentially to make it easier to control these machines, very fine movements.
So you're gonna have to excuse the crudeness of this here. I'm trying to do the best I can. So the spool itself, as you can see, we've got some kind of ridges in here, some round marks all around the spool. These are there to hold oil. Okay, it's supposed to lead in the lubrication of the spool valve. And then we also have these little dimples cut out of the areas of our spool. Now these are there for what they call it fine adjustment or creep. And basically what the point of these are is as the spool moves, just before it opens up the full flow to these areas, it allows a little bit of it to get through first. So if there was a wall right here blocking the DCV flow, and I moved the spool valve over, just a little bit would get through first. And that is what's there for the fine adjustments of the movement of your mini excavator. So there's a couple different ways that we could go about doing this, all right? One theory that I've kind of read up on is you just simply copy these cutouts. Instead of having two, you have four. So you'd put one at the 3 o'clock position, you put another one at the 9 o'clock position. Now this would mean that more fluid gets through as you moved the valves just a little bit. Now I don't know if that's actually going to help or hurt the fine adjustment of the machines. The other option that possibly could be explored is making these longer. So taking out a little bit bigger of a cut in the spool. And what that's going to allow you to do is move the handle less, and you would have a greater range of fine adjustment. So to me, I think that's probably the best route to go. I'm looking at maybe getting a prototype made and see how it works, or maybe just hooking this up to a mill and kind of let it ride, see what we come up with. But at any rate, I just wanted you to be aware of what's going on inside your valve body and how things work. So the last part of this, and I'm glad I have this spool because you can really see how precise the machining is on these spools. This is why it is extremely important to keep good fluid inside your excavator. All right, any contaminants that get stuck between this spool and the walls are going to grind a groove into it over time, and it's going to allow you to have some slippage or leakage internally on your valve body. And I don't know about you, but slippage or internal leakage is never a good thing.
I want to thank you for taking the time to watch this video and help the channel grow into the #1 place on the internet for information on these Chinese mini excavators. Until next time, Cam Sweet from the Garage Connection, and stay on those projects.